Welcome to MWN.com. Dr. M. Wilson is happy to welcome all to this session. Greetings from MWN.com. Dr. M. Wilson, author, publisher, professor of commerce and management and formerly vice principal and head of Department of Commerce, Nagercoil, is delighted in presenting this session. Thank you. Please subscribe the channel MWN.com. 4. Standard deviation. Standard deviation is popular and widely used measure of dispersion. It is the square root of the sum of squared deviations from average. Standard deviation has its own merits over other methods of dispersion, since it analyzes the deviations by squaring it. In this method, deviations should be taken only from the arithmetic mean. It is denoted by the small Greek letter sigma. Calculation of standard deviation for individual observations. The formula is square root of sigma x square by n. X indicates deviation from arithmetic mean. N equals total number of variables. If the observations are complicated one, or of very large size, then it takes time to find out the arithmetic mean. Further, it will be complicated to find out the deviations if the arithmetic mean is in fractional figures. To overcome these difficulties, shortcut method can be adopted to calculate the standard deviation. Formula for standard deviation under shortcut method is square root of sigma d square by n minus sigma d by n whole square. D refers to deviation from assumed mean, that is x minus a. Calculation of standard deviation for discrete series. The formula is square root of sigma f into x square by n. F equals frequencies. X equals deviations from arithmetic mean. N equals total number of frequencies. If the calculation of arithmetic mean is difficult, then the shortcut method can be applied to calculate the standard deviation. In the shortcut method, assumed mean can be used instead of the actual mean. Formula for standard deviation under shortcut method is mentioned here. D indicates deviations from assumed mean. F, frequency. N equals total number of frequencies. If the variable got common factor, then the calculation for standard deviation may further be simplified through calculation under step deviation method. Formula for SD under step deviation method is mentioned here. D' indicates deviations from assumed mean divided by a common factor, C indicates common factor for the observations, F indicates frequencies. Calculation for standard deviation for continuous series. The formula for standard deviation in the continuous series is almost same to the formulas for discrete series. In this series, the midpoints of the class intervals should be taken into account instead of the variable. Following formula would be used for calculating the value of standard deviation. I. Direct method. The formula is square root of sigma f into x square by n. X equals deviation from arithmetic mean, f equals frequency. N equals the total number of frequencies. E. Shortcut method. The formula is mentioned here. D indicates deviation of midpoints from the assumed mean. Step deviation method. The formula is mentioned here. D' is deviation of midpoints from assumed mean divided by a common factor. C equals common factor. Step deviation method is the most common method adopted for calculating standard deviation in continuous series. Illustrations are subsequently given. First illustration is related to individual observation. Standard deviation with 3-column table. In first column, the data as given in the illustration should be written. Through this, arithmetic mean is calculated by dividing the total of it by 7, that is total number of variables. In the second column, deviations of variables from the arithmetic mean should be calculated. In the third of its square of such values should be calculated. Then standard deviation is calculated. The illustration is calculated through assumed mean method. A middle value of the variables has been taken as assumed mean. All variables should be deducted from this value. This is known as deviation. The square of it should be written in the third column. The sum of it and the sum of deviations taken from assumed mean should be applied in the formula to know the standard deviation. This illustration is related with calculation of standard deviation by step deviation method. This is a discrete series. Assumed mean equals 150. 6-column table is prepared. First 2 columns contains variables and frequency is given in the illustration. In third column, D' is calculated with assumed mean is 150 and common factor is 25. Fourth column, D' square is calculated. In the fifth column, F into D' is calculated. In the last column, F into D' square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. This illustration is related with calculation of standard deviation by direct method. This is a discrete series. 6-column table is prepared. First two columns contains variables and frequency is given in the illustration. In third column f into x is calculated. Fourth column deviations of variables from the arithmetic mean is considered. In the fifth column x square is calculated. In the last column f into x square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. This illustration is related with calculation of standard deviation by shortcut method. This is a discrete series. Assumed mean equals 162. 6-column table is prepared. First two columns contains variables and frequency is given in the illustration. In third column d is calculated with assumed mean is 162. Fourth column d square is calculated. In the fifth column f into d is calculated. In the last column f into d square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. This illustration is related with calculation of standard deviation by direct method. This is a continuous series. 7-column table is prepared. First two columns contains variables and frequency is given in the illustration. In third column mid-value of the series in the first column is calculated. Fourth column f into m is calculated and fifth column deviations from the arithmetic mean is calculated. That's m minus c bar. This is called x. In sixth column, x square is calculated. In the last column f into x square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. This illustration is related with calculation of standard deviation by shortcut method or assumed mean method. This is a continuous series. 7-column table is prepared. First two columns contains variables and frequency is given in the illustration. In third column mid-value of the series in the first column is calculated. Fourth column mid-value minus assumed mean, that is deviations, are calculated denoted as d. In fifth column d square is calculated. In sixth column f into d is calculated. In the last column f into d square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. This illustration is related with calculation of standard deviation by shortcut method or assumed mean method. This is a continuous series. 7-column table is prepared. First two columns contains variables and frequency is given in the illustration. In third column mid-value of the series in the first column is calculated. Fourth column mid-value minus assumed mean divided by common value c are calculated denoted as d dash, and fifth column d dash square is calculated. In sixth column f into d dash is calculated. In the last column f into d dash square is calculated. Then the sum values should be applied in the formula and standard deviation is calculated. The important mathematical properties of standard deviation are 1. Combined standard deviation, 2. Coefficient of variation, and 3. Variance. 1. Combined standard deviation. The combined standard deviation can be calculated by following the same method of calculating the combined mean of two or more than two groups. This is denoted as small sigma 1 2. The formula is well presented here. Small sigma 1 2 denotes combined standard deviation. Small sigma 1 denotes standard deviation of the first group. Small sigma 2 denotes standard deviation of the second group. D1 denotes the difference between the arithmetic mean of first group with the combined arithmetic mean of the two groups, that's x bar 1 minus x bar 1 2. D2 indicates the difference between the arithmetic mean of the second group with the combined arithmetic mean of the two groups. That's x bar 2 minus x bar 1 2. N1 indicates the total number of variables of the first group. N2 indicates the total number of variables of the second group. Combined arithmetic mean can be calculated as N1 x bar 1 plus N2 x bar 2 divided by N1 plus N2. X bar 1 2 is the combined arithmetic mean, x bar 1 is the arithmetic mean of the first group, and x bar 2 is the arithmetic mean of the second group. The combined standard deviation of three or more groups can also be calculated by modifying the formula for small sigma 1 2 or standard deviation 1 2. Formula for combined standard deviation of three groups is well presented here. Illustration 17 is related to the details regarding a study conducted by two groups in a village about the monthly savings of families. Since two groups are given with respective standard deviations, standard deviation of 1 2 should be calculated through the formula. X bar 1 2 should also be calculated before that. Combined standard deviation can be calculated through the formula that was well explained before. Illustration 18 is regarding the marks obtained by students of three classes in a subject. since 3 classes are given with respective standard deviations. Standard deviation of 1, 2, 3 should be calculated through the formula. X bar 1, 2, 3 should also be calculated before that. Coefficient of variation. The relative measure of standard deviation is called the coefficient of variation. Standard deviation is only an absolute measure of dispersion. The consistency, uniformity or stability of data cannot be known through the standard deviation. Hence, the coefficient of variation technique is adopted to know whether the data is uniform, consistent, stable and reliable. 1. If the coefficient of variation is greater, then the data are more variable and less consistent, less homogeneous, less uniform and less stable. If the value of coefficient of variation is less, then the character of the data would be less variable and more consistent, more homogeneous, more uniform and more stable. The coefficient of variation can be measured through the formula mentioned here. The formula for the coefficient of variation was suggested by Carl Pearson. Variance is the square of standard deviation. Hence, variance is small sigma square. Hence small sigma, that is standard deviation, is square root of variance. Relation between standard deviation and other measures of dispersion. There exists a relationship between the standard deviation and quartile deviation and between standard deviation and mean deviation. Of these deviations, quartile deviation is the smallest and standard deviation is the largest one. The mean deviation lies between the standard deviation and the quartile deviation. Quartile deviation equals 2 by 3 into standard deviation and mean deviation equals 4 by 5 into standard deviation. Hence, standard deviation equals 3 by 2 into quartile deviation, or standard deviation equals 5 by 4 into mean deviation. Lorenz curve is graphic method of measuring dispersion. This method was devised by Max O. Lorenz, a famous economic statistician. It can be drawn by converting the value into percentages. It gives a clear picture about the dispersion of data from the central value. Procedures for drawing Lorenz curve. 1. Calculate the cumulative values of variables and frequencies. 2. Calculate the cumulative percentages of all the variables and frequencies. 3. X-axis should be represented with cumulative percentages to variables. Hence, it should have a scale of 0 to 100. Illustration 19 represent marks and number of students. In order to prepare Lorenz curve to ascertain standard deviation, 6-column table should be prepared. In first column, marks should be written. In the second column, cumulative marks should be written. That's 10, then 10 plus 40 is 50, then 50 plus 50 is 100. Like that, remaining values should be calculated. In third column, percentage of it should be calculated. That is 10 by 400 into 100 is 2.5, then 50 by 400 into 100 is 12.5. Like that, remaining values should be calculated. In 4, 5, 6 columns, same like that for number of students should be calculated. Here x-axis represents marks and y-axis represents number of students. Cumulative percentage values of marks and number of students should be taken for plotting points. All points should be joined to get the Lorenz curve. If a straight line is drawn from the origin at 45 degrees, it's easy to know the deviation of data from the central value, that is mean. Measures dispersion is to know the extent of deviation of the data from the central value. Though mean, median and mode are the central values, arithmetic mean is considered as the important central value. Hence all measures of dispersion are based on arithmetic mean. The methods are range, quartile deviation, mean deviation, standard deviation and Lorenz curve method. Range, quartile deviation, mean deviation are presented in the previous video. This video contains standard deviation and Lorenz curve. Hence, the exercise contains all the measures of dispersion. Thank you for the view. Please subscribe MWN.com.